So, our next presentation is from Paul. Paul will be talking about CSS, and without further ado, Paul, the stage is yours.
Thank you. Welcome everybody to Scriptless Attacks, where I try to convince you why CSS is my favorite programming language. And hopefully we have some people here who are already saying, actually CSS is not a programming language. So let's see what our AI overlords say to this. Is CSS a programming language? Of course they say, no, it's not. It's a style sheet language, and also functionality-wise, you cannot execute instructions or perform computations, no variables, no loops, no conditional statements, and so on. Okay, we'll see about that. So the big question is, why should you care about CSS? Of course, this will be around web and web exploitation and client-side web exploitation. So if I would phrase the question differently and ask about why should you care about XSS, cross-site scripting, then probably more people would already say, okay, no, that's bad, we want to fix this, or we want to report this. And if you know about XSS, then you might also notice that currently XSS mitigations are on the rise. Even if you find an injection vulnerability, then you might have an HTML sanitizer or a content security policy header or even a sandbox that completely disables JavaScript. So even if you have an HTML injection, you might not have any way to execute JavaScript. And for this talk, we're going to always look at this attack scenario where we have some user input which goes into a page as HTML, but some sanitizer removes all the JavaScript. So we cannot use any JavaScript in our attack. And the question is, can we have any impact without JavaScript? Or is this just a useless bug? And of course, the answer is yes, because we're in the CSS era. And to understand how we can have an impact, we first need to look at what are usual attacker goals, because well, if you find a XSS, then you just do the alert 1 pop-up to show somebody, hey, I have the XSS, nice. But an actual attacker would want to do more. So they might want to steal data from the application, from the user, or they might want to modify data, or they want to just delete data and destroy everything. So the question is, what can be done with CSS? Which of these can be done with only CSS, maybe some HTML, but no JavaScript? A little bit about me. I'm Paul. I'm a vulnerability researcher at Sonar. You might know us from Sonar Cube, static code analysis tool. And so also in my free time, I like to play CTFs and look at vulnerabilities and look at code. And also through CTFs, how I got introduced to how CSS can be used in web attacks and why it's nice. So today, we're first going to quickly look into the past to see for years what's been the thing that you could do with such an injection in our attack scenario, but this will not be a lot. So the majority of the talk will be spent in the present, where we will look at current modern CSS features and what an attacker could do with them. And then we're also going to look a little bit into the future, what are upcoming CSS features that might be implemented soon, which could also give attackers some nice things in their toolbox. And then finally, we're also going to look at defense to not leave you without any good countermeasures. So in the past, again, if we look at our attack scenario, we have some website, and now as an attacker, we can inject HTML and CSS, but again, no JavaScript. So the first thing that you could do is just deface the website. Paul was here, you're hacked, haha, your website is bad. But of course, this is fun for a script kiddie or maybe to do to a friend, but it's not real impact. And for example, in a professional setting where you're a pen tester or a bug bounty hunter, this doesn't really show your client, hey, there's real impact. So what you could do instead is inject a phishing UI into the page. Just with some HTML and CSS, you can make a fake login window, for example, that would convince the victim, maybe I do need to enter my password. This is the correct domain, it's the correct page, not a phishing page, because the phishing UI is in the real app. So this could be convincing. And I have a small real-world example here. This is from Discourse, which is a popular forum software. And when people post something there, they can put links into the posts, and then these links can have rich previews. For example, if you post a link to a GitHub issue, then they show the title and also the labels of that GitHub issue. And the problem was that the text from the labels was not escaped. So if you put HTML into your label on your GitHub issue, then when the rich preview is rendered in Discourse, the HTML would just be rendered inside. Discourse had a sanitizer, so all JavaScript was stripped out. But of course, with HTML and CSS, you could just insert a fake login window and or dialog, and you could even reuse the CSS that's already on the page to make it look very convincing. And for example, even your password manager would fill this in because this is on the correct page and it looks like a login field. So it would fill it in, and for example, 1Password these days auto-clicks on login. So yeah, there might be your password gone to the attacker. So this is already better. We can show some impact, but it still requires user interaction. The user could still smell that something is fishy and not do it. So let's see what else we can do, maybe with even less user interaction, which leads us to the present. And before we go into all the techniques that I'm going to show, we first have to do a very small CSS basics, because I'm not sure if everybody's familiar with CSS syntax and everything. So how can I even load CSS into my web page? So for example, I can use a link tag, and it just has a URL that points to some server where it loads CSS from, and this is then applied to the page. Or you can use an inline style tag, and then between the opening and closing tag, you can just put your CSS inside. And you can also have in your actual element a style tag, which then applies styles only to this very element. And in the CSS itself, this is what we call a selector. It's basically like a query language that expresses the following style should be applied to which elements. In this case, #foo means it should apply to all elements that have an ID foo, which the div below has. And then the selector's body consists of declarations. A declaration has a property and a value, and these then change the styling of the element. And if we look down to the style attribute, we can see there's only the declarations and no selector, because again, the style attribute only applies to the very element it's set on. Okay, so good for now. For the present state of CSS attacks, we're going to split it into four parts. First, we're going to leak things from attributes. Then we're going to look at how to leak things from text on the page. Then I have another section of other leaks that didn't fit into these categories. And finally, we're going to look at how to build more logic in your CSS. This has no direct impact, but it can help you to build more advanced payloads if you need it. So starting with the attribute leaks, here's a normal HTML element, and it has an attribute. The attribute's name is secret, and the value is ABC, and attribute values are always strings in HTML. So if we now want to find out what the attribute value is from CSS and maybe send it to our attacker server to exfiltrate it, there's a bunch of things in CSS that allow us to do this. For example, we have CSS attribute selectors, and these are selectors like the one we just saw in the example. They look a bit different. For example, there's the attribute equality selector. It's in square brackets, and then it says, hey, I want to apply to all the elements that have a secret attribute whose value is exactly ABC. And then afterward in the body, follow whatever styling we want to apply. Then there's also the starts with, where we can say, I want to select all of them that have a secret that starts with the letter A or any longer substring. The same can be done with ends with. Again, we see C and ABC, it applies. And there's also contains. So there needs to be a B somewhere in the secret value. There's some more, but these are the important ones for us for today. So let's start with our first technique. This is what I call an incremental attribute leak. And this allows to leak an attribute value character by character. Of course, well, we want to know why would I want to leak an attribute. In our example, it was just ABC, but there could be a CSRF token, some other authentication token in an attribute, maybe in a hidden element on the page that the user doesn't directly see. So there could be interesting things. There could also be just personal data that you want to steal from a victim. And this technique has two requirements. In the beginning, I already said we have sanitizers, we have content security policy that could block stuff. So here we need to be able to load styles from remotely, so not inline or not from the server that the application is running on, but from the attacker server, and also load images from the attacker server. And again, content security policy is something I already mentioned. This is a HTTP response header where the server of the application can tell the browser, hey, whatever you do, do not load resources from there, only from here. And for example, here, it has multiple directives. So the default source here says, by default, as a fallback, if not specified otherwise, do not load any resources, no scripts, no fonts, no videos, no whatever. But then for styles, it actually says, oh, by the way, styles, you can do whatever. Inline styles or from another server, I don't care. Same for images. So this content security policy would work with this technique, but for example, if either styles or images or both would not be allowed from the attacker server, from anywhere, then the technique wouldn't work. But let's see how the attack does work. So here we have again our element and our attribute, and this time we have a more secretly looking, token looking value. So we have some hexadecimal string, and we want to steal it from the victim. So the first thing that the attacker does is inject a bunch of CSS. And here we have already, we can see we have starts with attribute selectors. But there's also one more thing that's not a selector. And this is called an add rule. In this case, it's the add import rule. And this just tells the browser, hey, you need to load even more CSS from here. And this points to the attacker server. But the attacker server does not immediately respond. So while this connection is open and the browser tries to or waits for more CSS to come, the browser already applies the CSS that's already there. And so here we have a bunch of selectors. I didn't show all of them to save some space, but basically for each hexadecimal character, so for each possible first letter in the secret, we make one selector. Does the secret start with 0 or with 1 and so on, or with F? And there we see, okay, yes, the secret value does start with an F. So now the browser applies the style, and what the declaration inside tells the browser is set a background image to the image from this URL. So in order to show the background image, the browser has to request it and load it from the attacker server. And this tells the attacker server now the first letter of the attribute value. And now that the attacker knows this, now the attacker can respond to the pending request for more CSS. And the returning CSS looks similar but slightly different than the first one. So again, it tries to load even more. But now we can see the starts with selectors already include the F, because the attacker already knows it starts with an F. So now we want to find out the next character. So we look, starts with F0, F1, and so on. And then again, F9 matches. So another background image is loaded from the attacker server. The attacker knows one more character. And this loop repeats until the attacker knows the whole value. That's pretty cool, not that hard. And I also have a small real-world example from this. This is from an exploit chain my colleague Yaniv found in MailSpring, which is a desktop email client. It's built with Electron, so also web technologies. And in there, remote styles and remote images were allowed, but he needed to leak a file URL in order to finish his exploit chain. So he was able to use this CSS technique to leak the file URL and then continue the exploit chain. If you want to read more, you can check out the blog post. But let's move on. Now we have a different technique to leak attributes. Why two, you might ask? So here we can already see in the requirements, this time we only need inline styles and no remote styles. So again, thinking back to a content security policy, maybe the content security policy in this scenario blocks remote styles from the attacker server, and we can only use inline styles. So this technique also works in this more restricted case. We still need remote images to exfiltrate the data to the attacker server. And here, instead of doing an incremental leak, character by character, we're going to leak parts, substrings of the value in parallel. So let's see how it works. Again, we have our value. And this time, first, the attacker has to generate a bunch of values, which is all the possible two-letter combinations based on the alphabet of the secret value. So again, it's a hexadecimal string. So we have a bunch of combinations here, 0, 0, 0, 1, up until FF. And then the attacker generates CSS selectors out of this and injects them into the page. But this time it's not the starts with selector, but the includes or contains selector. So when the browser tries to render this, it will check each selector, and for the first one it will check the attribute value. Does it contain the substring 0, 0? No. Okay, next one, 0, 1. Oh, okay, next one. Up until 7C does match. There is a 7C inside. So this selector matches, and again the request is made to the attacker server for the background image. So now the attacker knows, okay, 7C is somewhere in the value. Then it continues, 9.7 matches, request is made, continues, F9 matches, request is made, and so on, until the attacker knows all the possible substrings that are actually included somewhere in the value. But how does the attacker now go back to the actual combined value? The order of the network request doesn't give away anything because it's either random because of network jitter, or it's in the order that they appear in the CSS, but never in the order how they appear in the value. But what the attacker can do is simply start with any chunk. In this case, we use 7C as the first one, and then check, is there maybe another chunk that ends with a 7? Yes, there is. So it's very likely that these were next to each other, overlapping actually. And so we continue, something ending with 9, yes there is, okay, we know more. Something ending with F, no, okay, then maybe we try on the right side. Something starting with a C, yes, starting with an A, yes, starting with an 8, yes, and continue until we now stitched back together the whole value. Of course, there can be ambiguities here. We, for example, see that the next chunk would also start with a C, so the attacker wouldn't really know if CA or another one with a C would be the correct one. And in this case, you would need to increase the length of the substrings from 2 to 3 or maybe even 4, because this decreases the likelihood of collisions. It does increase the amount of CSS you have to inject, so it always depends on your injection scenario. But you basically have a trade-off there. And here we also have a real-world case study. This is from a cross-site scripting chain we found in ProtonMail, the end-to-end encrypted privacy and security preserving webmail service. And here it was exactly the conditions. We had inline styles and remote images. This is common for webmail content security policies. And here, to actually get the XSS, we had to steal a blob URL. And so I used this CSS contains parallel chunk stitching leak to actually get it, and then we could continue the chain, send another email, and actually execute script in the page and steal people's emails and secret keys even. All right, one more attribute leak. This is a fairly new one. And here we can leak an attribute value with a single request. Pretty cool. For the other ones, we had to do multiple requests in a row, and here only one. The requirements are the same as for the first technique, so this is basically a nicer version. We need remote styles and remote images. There were recent changes to the CSS attribute function, and Slonza on Twitter nicely wrote up why and how this new technique works. So let's see. Again, we have our attribute value, and now normally, if you want to use the attribute or attribute function in CSS, how you normally would do it is you do a selector, you select an element that has a secret attribute. Here you see the attribute selector without a value, just selects if there is this attribute. And then we see the colon after. This is some special CSS stuff, but in the end, we set the content property to the value of the attribute, and this would just show the text on the page. So this is not relevant for the attacker, just how you would normally use this function. So what the attacker does instead is use this function to get the attribute value, put it into a variable or custom property, and then we just use it as a background image URL. But how we do it right here doesn't work. The URL function cannot be used in this way, but instead there's a different one that does almost the same, the image set function, and this can be used to receive a string and request it as an image URL. And so now, because this is a remote style, it was loaded from the attacker server in the first place. So now any URLs inside of the CSS, if they're a relative URL, they're considered relative to where the style came from. So in this case, the secret value does not start with http://, so it's a relative URL. And so it's requested from the attacker server, because that's also where the style came from. And with a single request, we have the whole value. Pretty cool. So let's continue from attribute leaks to text leaks. Attributes were cool, and there are cases where in attributes you have data that as an attacker you actually want to leak, but text is of course better. I mean, on every web page where you do have some sensitive information, usually they're displayed as text at some point. So if we can leak arbitrary text from a web page, this already gives us more as an attacker to steal. The problem is, in CSS, there's no selectors to select specific text as we had for attributes, so we need to be a little bit creative to still learn information about text just with CSS. So the first technique here is called the font ligature incremental leak. And similar to the first attribute thing, we do an incremental leak character by character. And here we use fonts. So for this, we need remote styles. We also need remote fonts. And I'm going to use remote images because you already understand how the exfiltration works with that. But in theory, you could also use the fonts for exfiltration if you want to get rid of the images. So before we jump into how it works, we need to understand what's a font ligature. So normally in a font, the font has a mapping between, hey, you want to render this character, here's how to draw it. And if you have two characters, F and I, even if they're a little bit overlapping because the letter spacing is a little bit too tight, those are two different drawings or two different glyphs in font lingo. But if you want to make your text look very nice, you can specify that a special combination of two specific characters should always be drawn as this one drawing. So here we reuse the upper part of the F to draw the dot of the I. Looks much better, yes, yes. And this is called a ligature. Basically, when you have one drawing that is drawn instead of two or more characters. So how is this useful? Here on top we have our element with the text that we want to leak. Of course we want to leak the password. And the CSS that the attacker injects, or a snippet hereof, I had to truncate it down because of space. Here at first we have something that we already know, an import. This makes a request to the attacker server to fetch more CSS. Again, the attacker stalls this and doesn't respond immediately. So next up we have a font face declaration. This basically tells the browser, hey, in the CSS now I will be using a font called leakth, and please load it from this URL. So this is also loaded from the attacker server, and we have a bunch of these font faces for all the possible two-letter combinations. This will be more than in the hexadecimal example, because now we have uppercase, lowercase, and all the characters, maybe even numbers, depends on the text. And then we specify an animation with the add keyframes add rule. And here I only show one keyframe, which is at basically 67% of the animation timeline. Apply this style, but there's a bunch of more around it. And then finally we apply this animation to the div element. And what this does is it will cycle through all the keyframes, and in each keyframe the browser will try to render the text with a different font. And when it arrives at this step that I'm showing here with the TH font, then it uses the font loaded from the attacker server, and this font specifies a ligature for TH, but it actually specifies how to draw this, and it just makes it very wide. So we can see here we have the TH, and now the font applies, so this character is now very wide and makes the whole element bigger. And in CSS we can now detect the size change and then do a request to the attacker server that we know, when I tried this font, the element became bigger, so this substring th must be in there. And now the attacker again responds to the first CSS request and continues with the next step, and just like with the attribute thing, now the font does not only do th, but now we already know it starts with th, so now we try the next character, tha, thb, or the, which, when the animation runs through, eventually fits. Then the the becomes bigger, a request is sent again, so again we do the loop to incrementally learn the next character of the text until we have enough. And so we leak the full value, including the password. That's quite nice, but maybe we are again in a more restricted environment. Maybe we again can only use inline styles and no fonts from remote or from anywhere, and we still need the remote images to exfiltrate. So let's see what we can do here. We do have again the password in our text, and I will remove the starting and closing tag here because we just care about the text. So the first thing that the attacker CSS does is apply a monospaced font. This makes every character the same width, but this doesn't bring us anything for now. So the next step that we're going to do is we make this element only one character wide. So, and then we also specify, okay, break everywhere, not just at word boundaries. So what this does is now all of the characters are stacked on top of each other. So far, so good. Still doesn't bring us anything. Let's move this around a bit so we have more space to put more CSS. So next up, we are going to look at how actually the monospaced font, how it's specified. Oh no, sorry. First, this step. Here we move some characters into the first line. Maybe above the S, you can see a very small text there. This is basically the first line pseudo selector. Basically, you can say, hey, of this element, apply this style only to the first line of text. So if you have a big paragraph, only the first line should be red or whatever. Not sure why you would use it in the real world, but for the exploit, it's nice. So all of the characters that we basically don't care about, the password is, we only care about the actual password, we move them into the first line by making a very small font size for the first line so that exactly 16 characters fit into this one line. And now we can see that only the characters that we do care about are stacked on top of each other. So let's now go into how the monospaced font thing works. Normally, you specify a font face and you say, well, I call this font Ubuntu Mono, and instead of loading it from a remote URL, we just say, just use the locally installed font. Everybody has some fonts installed on their machine, and there's a bunch of default ones that cover like most machines, or depending on the OS, you might have to detect this. But for example, on my machine, I have Ubuntu Mono installed locally, and this cannot be blocked by the CSP. Even if the CSP says no fonts at all, this local loading can never be blocked because it's not actually loading a resource over the network. It's already there, basically. And so normally in the div, we would say, yeah, font family is Ubuntu Mono, exact same name as in the font face declaration. But now we add an additional font declaration. This one we call leak S. And there's a difference here. Now we add one more declaration. We say with a Unicode code range, this font only supports a single character, and that is the lowercase s. And now when the browser tries to use this font, it can only use it if there's an S. Otherwise, it doesn't know how to render the character. So in our div, we say first try to use the leak S font, and only if that doesn't work, use the other one. So everything still looks the same because both are essentially the same font. So now we're going to see a difference by adding one more declaration. And now we override the height, basically, of the character. And this only applies to the lowercase s, because we only do this for the leak S font and not for the Ubuntu Mono font. And now you can already see both s's are somehow taller, or there's some white space compared to the other characters. And we will do this for all the possible letters in the alphabet. And now we also give each letter a distinct height override. So here I made a small table. For the letter D, we made it 40% larger, the letter F 60%, so it just maps to their letter position basically. So we have a unique mapping between each letter and how tall it is. Still, you might ask, how does this give us any information about the actual text? And we will do that now. So because of the percentage and by controlling the font size, we also know how much of this height is in pixels, not just in percents. So now we know each character has a unique height in pixels, and we can start to measure the height. But we can only do it for the whole element, so we will start looping. So right now, both the old and the new height are the same. 211 pixels is the height of the whole stack of all the characters. And now, with an animation, we start to loop, and we move one more character into the first line. We made the font size even smaller. Before it was 16 characters, now 17 characters fit into one line. So the S disappeared from our stack and is now in the first line. So now the total height of the actual stack is smaller. And if we calculate the difference, we can see it nicely maps to one of the unique heights of our characters. So we look into our table, we see 29 pixels difference, so the S or the character must have been 29 pixels high. That must have been an S. And now we know it was an S, so right now we could request a background image from the attacker server to tell the attacker, hey, the first letter was an S. Then we do it again. We move one more character, the W, into the first line. Now first line fits 18 characters. Again, we have a difference that nicely maps to a specific character because all of them have a unique height. So we know the W, then we do it again, we know O, and we do it until we know the whole password. And in the background, we also send it to the attacker server. So this is pretty nice because we only needed one big blob of inline CSS, and with some animations and some funny tricks, we actually made a kind of loop that continuously measures the height, moves stuff around, calculates the difference, and maps that to characters. Pretty nice. Here we also have a case study. Unfortunately, I cannot name the actual target, but it was some cloud service where there was a CSS injection or HTML injection in a page, and on that page there was also the possibility to generate API tokens for a user. We could use inline styles and remote images, so it perfectly fit to this technique. And when the victim visits the page, the CSS steals the API token in the background. In our demo or in my explanation, we saw all the moving around and stacking of characters, but the CSS can just hide this away from the user so they don't know what's going on. And the payload can steal the API token, and then the attacker can impersonate the user, which is not so good. All right, now we can jump into a few other leaks. And here, for example, this is not only leaking, but we already observed we can do HTTP requests just with CSS. We can use the background image thing. We can also use content or the font source. We can also use the @import rule. And all of these will do only GET requests, so we cannot do POST requests. But instead of sending them to the attacker server, we could also send them to the server of the actual application. And because it's a same-site request, all the cookies would also be sent with it. So this is kind of going into the direction of cross-site request forgery. But of course, normally, if you build your application right, GET requests don't really modify anything on the server. But maybe they fetch some information. And in very rare cases, you can even try to interpret the HTTP response data. So for example, if an image is returned, you can measure the dimensions of the image just with CSS. And it might tell you, for example, is the user logged in and have access to the image, or is some placeholder loaded, or something like this. So it could be part of a bigger exploit where you only want to target a specific user and use this to fingerprint a user. Then for the HTTP request loading thing, you could also do a timing side channel. You can basically measure how long the image takes to load. Or it doesn't have to be an image, actually. It can be any HTTP request, even if the response is not an image. We can use the same technique. And here we use the content property to set the image and make it part of the page. And once it loads, the size of the element changes. And even if it's not an image, there will be this broken image placeholder thing. And even that changes the size. So we can detect this size change with a container query. And in the background, we start an animation that counts up from 0 to 10. And at the point in time where the size changes, we just take the current animation value, and then we know how long it took. And we could, for example, send this information to an attacker server via like a background image, or we can use it in our CSS to do more stuff. And this could either also give you information about it. Maybe this is a specific user that's logged in, or maybe if you have on the server side some kind of timing side channel, for example, if the database query is being done and a result that doesn't contain anything returns faster than a result that matches something, then you can combine this to steal information from, for example, an API endpoint. All right, let's now also look a little bit more into how we can do logic with CSS. We've already seen some form of logic, but let's break it down to like the lowest possible form of logic, which is bits or true and false. And here we can use the so-called space toggle trick. So we define a custom property that represents true, and this is just a single space, a white space character. And we also do one for false, and this uses the initial keyword. And in CSS, the initial keyword tells the browser whatever value this property has right now, just revert it back to the original baseline style of the browser, nothing that the page did. But because it's a custom property, there's no initial value. So the browser doesn't know what to fill in, so the value becomes basically an error, an invalid value. And with this, we can build logic gates. So for example, to build an AND gate, we just put two variables next to each other. Now if both are the true value, both are white space, then both variables resolve to white space, and so the whole value of this new thing is also white space, so it's also true. If either of them is false, then the whole expression becomes invalid, because putting in one invalid value into an expression, the engine doesn't know how to compute the results, so everything is invalid. And we can also build an OR gate where we use a variable and use the other variable as its fallback. So first the browser tries to use A. If that's an invalid value, it will try to use the fallback, which is B. If that's also invalid, then the whole thing becomes invalid or false. But if either of them is true, white space, then the whole thing resolves to this white space. And there's a nice demo that shows how you can use this to build more logic, which is this nice 7-segment display. It's built by Jane Ori. And it's interactive, so we see the 7-segment display over there on the right, and now it displays 0. And these checkboxes down below correspond to the bits that you would set to specify a number. So if I set the lowest bit, the 1 is displayed, and you can even see nicely here what type of logic gates were used to build this logic. So if I click other things, 2 and 1 is 3, yes, it works, or we have 6, and so on. So you can already build more advanced stuff. And what you can, of course, then do, what the next logical step is to combine all these logic gates into a whole CPU, of course. So you define some registers. Instead of having single bits, you put them together to bytes and whole registers. Then you can build an ALU, where you can calculate stuff, add, subtract, and so on. Memory is a bit tricky, but it can be done. And at some point, you will notice that, for example, Chrome's CSS engine only supports 2 to the power of 16 variables, which is like 64K. After that, you cannot use more, so you're a bit constrained into how complex your CPU can be. And what you can then do is you take a random, simple RISC architecture CPU, like this RISC-16 one, which is from some academic homework of some university where people had to implement this in some hardware language. And then you turn it into a bunch of CSS, and you have your CPU and can actually run stuff on it. So of course, that's what I built. 2 years ago, or 1.5 years ago, I made a CTF challenge out of this. I'm not only playing, I'm also hosting CTFs. And the goal of the challenge was to find the password. Maybe some of you know the original game, the password game, where the password rules become increasingly annoying and you still have to find a password that matches. In this challenge, you didn't even know the rules that you have to fulfill. So first, the players had to reverse engineer the CSS to understand, wait, this is kind of a CPU or virtual machine. Then they need to understand how the CPU works again, they only have these weird-looking gates and not the actual logic. So they have to understand which instruction would do what. And then at the end, once they know that, they can reverse engineer the program actually running on this CPU. Back then, I still had to use a little bit of JavaScript on top. Does it work? Yeah, I'll continue with this. So for the challenge, people were luckily for them able to use some what we call cheeses in the CTF, which is basically you find a way to solve a challenge easier than intended. So for example, here they were able to observe how long does the program on the CPU run without actually understanding completely how the CPU internals work. And even from that, you can byte by byte try to find the value. I think otherwise the challenge would not have been solvable. Actually, 9 teams solved it, so kudos to them. If you want to try it out, you can go to the URL and find the challenge there. I don't know if I can recommend it, but you can see that the CPU kind of works. All right, now we're done with the present part, so let's look a little bit into the future and see what upcoming features are there in CSS. These are all in the spec drafts, or almost all, so they might change how they look, or they might never be implemented or accepted. But for example, string concatenation could be an interesting thing. For the single request attribute leak, we needed the CSS to be loaded from the attacker server in order to have a relative URL that also gets requested from the attacker server. But with string concatenation, we could do this ourselves. So we could use inline styles to say like, hey, we'd use the secret value, for example, from the attribute, and just concatenate it to the actual base URL, the domain, and then the browser would always send it to the attacker server, even if the style itself is not loaded from the attacker server. Then they're talking about type conversion functions. For example, we've seen this with image set, where we put in a string and then it's interpreted as a URL. But maybe soon we can do this explicitly, for example, to convert strings into URLs, or numbers to strings, strings to numbers, and so on. So this makes it more flexible to handle different types of data without using a lot of CSS quirks to achieve the same. Then this actually was already implemented, so it's not quite future. We can use if in CSS now. They actually added the if keyword or function. So this basically makes the space toggle trick that I used for the CPU obsolete. Maybe I should build a new version that's smaller. And here you can see, for example, based on the text color of an element, we can set the background color. But yeah, the possibilities are infinite. It's just like an if-else that you already know from all the other languages. Then there might be dynamic identifiers. So, for example, the name of an animation is an identifier, and right now you cannot dynamically say, oh, take this string and then this number or this other string, combine them and make an identifier out of that. You would have to do a different method of selecting the right animation, but maybe with this we can use the ident function to actually dynamically create identifiers. So this can create more complex logic in your CSS. It's kind of some kind of polymorphism. Maybe it will even apply to variable names. This would be even more powerful. We'll see. Then there will also be likely custom functions. I think this is already on the roadmap to be implemented in Chrome, if I'm not wrong. And this will make it very nice that you don't have to repeat certain parts of your CSS logic. So it basically allows you to create smaller CSS payloads. So, for example, if you're constrained into how large your injection can be, your text that you're injecting, then this can help you to reduce the size. So it looks very similar to a custom property, but instead of just using the value, you can pass a parameter and get back a return value. So this could be interesting. All right, after all the attacks and the techniques, let's see how we might be able to defend against this. And so, in order to defend it, let's check what the common patterns are among these exploits. And almost all of the advanced techniques require top-level styles. So we need to be able to use selectors like the attribute selectors or the first line pseudo-selector, or we need to use add rules to declare fonts, animations, or do imports. So if the attacker can't use these top-level styles, then all of these techniques don't work. So one example would be to use an HTML sanitizer to block the elements that can be used to declare top-level styles. If you block the style tag and the link tag and remove it from the user-controlled HTML, then there's no way to declare a top-level style, because the only thing left to declare styles is the style attribute, and there we only have the declarations and not the selectors or add rules. Or we can block with the content security policy inline and remote styles, and then there's no way to define any styles. And again, we wouldn't be able to use the style tag or the link tag, and with that, the attacker can't inject their payload. If you really need to let the user do some CSS, then you could go and use a CSS sanitizer. But in general, like, there's not as many CSS sanitizers around compared to, for example, HTML sanitizers. There are some examples, the Ruby package sanitize or MediaWiki's CSS sanitizer should work. I don't know how good they work. One of the problems is that CSS is evolving quite quickly, especially compared to HTML. They're adding a lot of new features every year, so the sanitizer would need to keep up and actually be always able to parse the most up-to-date version of CSS or the syntax, because otherwise it might be easy to smuggle something through. And the other problem is if you do sanitization, it doesn't matter if it's CSS or HTML, if you do it on the server side and not on the client, then you have to have your own parser on the server, because in the browser parses it for you, but on the server side you have to bring your own parser, and the parser on your server will likely be slightly different from the browser. And so if both are parsing different things from the same text, then the sanitizer can't be trusted to actually remove everything that might be malicious, because it might not see something as malicious that in the browser gets rendered as some CSS that does bad stuff. So server-side sanitization is always a not so good thing, in my opinion. All right, let's start to wrap up here. We've seen a lot. So first of all, let's get back to our attacker goals and see which of these did we fulfill. Of course, we did steal data, but we also have to say that we only stole data, or mostly stole data from the page. So actually requesting data from the server and stealing, exfiltrating that, in some rare cases it might be possible, but yeah, you're usually limited to stuff on the page. But there's still enough interesting things that you might want to steal from there, so I think that's a yes. But for modifying and deleting data, it's basically both a no, since we cannot really do like requests to the server that would modify something in normal circumstances, and we also cannot access like local browser storage. We cannot modify or delete stuff. Then you might ask, where can I read all the details? If you might want to use one of the techniques, then yeah, you only seen snippets or the rough idea, but we only really scratched the surface of A, what's possible, and B, how it's implemented. We didn't have time to go into all the implementation details, so I'll be creating a collection of resources that ideally explains all the techniques and gives you at least an example proof of concept that you could adapt, and I'll release it when it's done. I cannot promise a date, but keep an eye on it. So finally, I hope I was able to convince you that CSS injections are more than just defacing the page or embedding a phishing UI, and that actually CSS is a very helpful tool in the tool belt of a web attacker. So if you're a pen tester, bug bounty hunter, or similar, and you're attacking web applications, then you should not sleep on CSS. You should at least keep it in mind and know when it can come in useful to finish your chain or without any JavaScript leak stuff. And finally, you should keep in mind that CSS evolves quickly, so a bunch of new techniques might be available in the next months and years once they add more features to CSS. And most importantly, I hope I convinced you that CSS is a programming language. We had our loops, we had our instructions and everything, especially with the CPU. And also to prove this, it was a bit painful, but I did build the whole slide deck with just without any JS, even like the key press detection. So there's in the background always running some, can I actually go there? Some debugging, oops, loop. You don't have to understand what it's doing, but yeah, it works. And with that, I'm done and happy to answer any questions. And you can find my research team and me on the socials. Thank you.
So, thank you very much. Any questions? Yes.
Can you put the slide deck on GitHub?
Yes, I will release it. So yeah, you can also then check it out and see how many lines of code of CSS it is.
Any more questions? Yes.
Hey, thank you for the good talk. I think 5 years ago I did a challenge with a keylogger over CSS. Is it still possible? Something like that?
Well, now the audio works again. Good. So yeah, keylogger and CSS.
Okay, thank you.
Okay, any more questions? No? Then thank you very much again.